All right, here we are, percent change, which is, we're talking about percent increase or percent decrease, which follows a different formula than the rest of the percentages that we're going to do. So this is why it's getting a different section. It does have a different formula, so you'll want to make sure you write it down, you remember it, so that when you see, again, those keywords, percent change, they can give you the variations, percent increase or percent decrease. You want, those bells to go off that you are using a different formula than all of the other percentage stuff that we've done so far. So the formula for this, I'll give that to you first, is change divided by original. And really, if you're thinking like, okay, well, what does change mean? How does that help me? Really what we're looking at is the new minus the original divided by the original. Now, if you can't remember if it's new minus original or original minus new, that's okay because ultimately it doesn't matter. And the reason it doesn't matter is because you can look at this and figure out if it's an increase or a decrease. So like looking at number 1 and looking at my, my first numbers from 45 feet to 92 feet, I know that I'm going from 45, so that's my original, and then I'm going to 92 feet, which is my new value. When I put this in the formula, I'm going to put 92 minus 45, and then I'm going to divide by 45 because that is, again, where I started. That is my original. So really the important thing here is to remember that you're dividing by the original. Now, the reason why we don't have to be super careful up top is because if you look at this, 92 minus 45, 45 minus 92, you're going to get the same number value. One of them is going to be positive and one of them is going to be negative. If you plug it in with the new minus the original, it will give you the correct sign. So positive means increase, negative means decrease. But you can also use just the common sense logic that you have to look at your numbers and say whether or not you're increasing or decreasing. So if you're going from 45 to 92 feet, then this is going to be an increase. So even if I were to get the number answer incorrect, I still have it half right because I know that that is an increase. So therefore it's going to be a percentage increase as well. So here's where you do need to be careful. You are smarter than your calculator because if you just plug that into a 4-function calculator, it's going to read the order of operations correctly, whereas that is not what you want to do here. So it would divide before it subtracted. However, you want to subtract before you divide because you want to figure out what that value is on top, the 92 minus 45. Just a word to the wise, you don't want to trust doing too much in any 4-function calculator or any operation in a 4-function calculator. It's really a calculator built to do one step at a time or handle one step at a time. The reason is because you can't see a lot on your screen. And again, you may know something when you're doing it by hand, but when you plug it in your calculator interprets it differently than you did. So if you insist on putting things in your calculator like that, make sure you hit enter after the subtraction. And what I mean by that is this. I'm not going to plug this whole thing into my calculator straight away. I'm going to do the subtraction on top. So I'm going to do 92 minus 45, and I'm going to get 47. And then I'm going to still have 45 on the bottom. So you see that in order to get this division problem, I needed to subtract first. Then I would again use my calculator. I would do 47 divided by 45, and you get 1.044, and repeats forever. Now, looking at this is a decimal. This is not a percentage. So in order to get to a percentage, because I want a percent increase or a percent decrease, I need to then go from decimal to percent, which is moving my decimal 2 to the right. And then I need to round correctly because it said round to the nearest percentage. Usually when we're dealing with percentages, we don't want to deal with decimals. It's one or the other. So I'm going to move my decimal 2 to the right and end up right here, which is 104.4. And that 4 does nothing to the other 4, to the 4 in the ones place. My answer is going to be 104%. And I'm done. All right, so for number 2, my original is 74. My new is 85. So again, this is a percent increase because I went up. And it's as easy as that. Up is increase, down is decrease. I'm going to plug it into my formula, which says I have to do 85 minus 74 over 74. Remember, original goes on the bottom. And I can go through and kind of see what my original would be each time. Now, I'm going to do my subtraction. So 85 minus 74. I'm going to keep my bottom, so I have 11 over 74, or 11 divided by 74, and this is where I can plug it in my calculator, and I get 0.148. Now, I have to take 3 places after the decimal, and the reason for this is because, again, this is a decimal, and I want to turn it into a percent. So in order to turn it into a percent, I have to move 2, which is going to give me 14.8. But I want to round to the nearest percentage, which that 8 makes the 4 go to a 5. So this is a 15% increase. And I already wrote it here, but just make sure, you definitely want to denote that somehow. So that's the reason why I take 3 places after my decimal. All right, number 3, I have my original, which is the 94. I have my new, which is the 34, because I'm going from 94 to 34. So I am decreasing. I'm going to have a percent decrease. When I plug this in my formula, I get 34 minus 94, and I put it over 94 because, again, I want my original on the bottom. So 34 minus 94, now you see this is where I get a negative. If I do this in my calculator or I do it by hand, either way, I'm going to get a negative. And what that tells me is that I have a percent decrease. Right here, that tells me I have a decrease. So 60 over 94, I divide that, and I get, again, negative 0.638. I take it out 3 because I have to do my rounding. I move my decimals 2, or my decimal 2 places, and I get negative 63.8, which the 8 rounds the 3 to a 4. So I get negative 64%. Now, the negative is not, do you have to have it there? Not necessarily. You've already said that it's a decrease. So you've already denoted that this is a decrease, but that should match that negative sign in your percent. All right, number 4, we have our original being, 117, and we have our new being 91, because I've gone from 117 down to 91. I'm going to plug it into my formula, but I know that this is, again, a decrease. And I get 91 minus 117, new minus original, and I put it over the 117. When I subtract 91 minus 117, I get negative 26, again alerting me to the fact that I have a percent decrease, and I have 117 on the bottom. When I divide 26 by 117, I'm going to get negative 0.222222, repeating. knowing that I now have to move my decimal to, I get negative 22.2. That final 2 in my 10th spot is not going to do anything to the 2 in the 1 spot, so I have negative 22%. And I knew it was a decrease, but I can also denote that by the negative symbol. All right, so looking at the word problems for these, again, you're going to be alerted to the fact that this is a percent increase or decrease because it's going to say something to that effect. So you see in number 5, it says percent of markup, which is essentially like saying percent increase. Number 6 is percent of change. So again, percent of change, it's not telling you if it went up or down. You have to figure that out. And again, in number 7, it says percent of change or percent change. So you see how the wording, it will ask you for either a percent increase, decrease, or change. But we're going to do the same thing. We just have to figure out original and new. So Keela's clothing store buys coats for $50 and then sells them for $80. So I'm going, if I write this how my other ones were up top, I have from 50 to 80. That means my 50 is my original, my new is the 80, and then I can go on from there. They want the percent change. So I do 80 minus 50 over 50. Again, original goes on the bottom. I get 30 over 50. If I wanted to, I could knock out those zeros, and I really have 3 divided by 5, which is 0.6. Now, what happens if I don't have the 3 decimals to round? To round or to move my decimal. That's okay, I do it anyway. Just like I learned last week with that metric system and saw earlier tonight. And I would get 60%, and it was an increase or a markup. All right, the number of beachgoers last summer averaged 255 people a day. This summer, the average number of beachgoers is 288 per day. So if I write it like I had up top, I went from 255 last year to 288 this year. Okay, again, you have to look for those keywords. So last year, this year means it started at 255, it's ending at 288. My original is 255, my new is 288. I set that up for myself. I do 288 minus 255 over 255, again, original. I do my subtraction. I get 33 over 255. I divide. I get 0.129. I move my decimal 2 to the right. I get 12.9. The 9 rounds the 2 to a 3. So I got a 13% increase because, again, I went up from 255 to 288, and you knew that it was increased right from the get-go. In 1967, a 30-second Super Bowl commercial cost $40,000. In 2000, a 30-second commercial cost $1,800,000. What was the percent of change? Now, there's a lot of numbers here, but ultimately, the length of the commercial makes no difference to us. It could be a 30-second one. It could be a 2-minute commercial. That is not relevant. That's extraneous information. So we're just going to cross that out. Now, the years matter only because, again, if I want to write it from this to this, okay, I want to go with the original or the older amount to the newer amount. So obviously the 1967 is going to go in that first slot, and the 2000 year is going to go in that second slot. So I can put them in. It went from 40,000 to 1.8 million or 1,800,000. So now I set myself up. I'm going to do 1,800,000 minus 40,000 over 40,000. Just be careful with all your zeros. So when I subtract, I get 760,000. And we're talking dollars, and that's over 40,000. So when I divide, I get 44. Now you have to remember that is a decimal. You always need to move your decimal 2 times to the right, and that is going to make this 4,400%. And this makes sense because if you think about 100% change, that's doubling, right? Doubling would be 40,000 to 80,000. We went from 40,000 to $1.8 million. So this is going to be a huge rate of change or percent change, and this is going to be a huge increase. All right, try some on your own, come back with questions, and let me know how it goes.